Okay, so now let's say that we have a polynomial. Whatever the polynomial is, we want to first get it into one of these four forms. We want either the polynomial, which we'll just call f of x, to be less than 0. We want the polynomial to be greater than 0. We want the polynomial to be less than or equal to 0. Or we want the polynomial to be greater than or equal to 0. So basically, what that means is we're going to have whatever they give us. We need to make sure that one side of the inequality is equal to 0 before we can proceed. The reason for that is this, and I'm going to show it to you graphically here, and hopefully this will make some kind of sense. If I gave you just some kind of a quadratic, general quadratic function, whatever that quadratic is, maybe the quadratic looks something like this. Well, what I'm hoping that you guys can see here is that there are places where the quadratic equals 0. That's going to be right here. Right there and right there. There's two places on here that the quadratic equals 0. What if we only want where the quadratic is greater than or equal to 0? Or let's just go with greater than 0. If I'm only interested in the place where this quadratic is greater than 0, that means it must be above the x-axis. This right here, this whole section, all of this, is where the quadratic is greater than 0. But let's say that I'm interested instead in where the quadratic is less than 0. Well, then I'm talking about all of this section down here where the quadratic is less than 0. So I've got different spaces here. I've got different intervals, and the intervals are separated by where the quadratic is equal to 0. The important thing there is where the quadratic is equal to 0, those points specifically are what we call our cut points. Cut points or boundary points. I believe your book probably uses boundary points. I call them cut points. So if you hear me call it a cut point, it's just a boundary point. It's exactly the same thing. And that's going to help us to be able to figure out where the inequality gives us a true statement or a false statement. So again, if I was looking for where this is less than 0, everything that I circled with the red there, that would give me a true statement. So every value in between the boundary points would be true. If I was looking for where it's greater than 0, then everything I circled in green would be where the statement is going to be true, and it would be on the outside of my boundary points. So let's go ahead and take a look at an example here and see if we can actually figure this out with actually using a real life example. So example 1, go ahead and scroll this up. Example 1. We are going to try and solve the inequality 2x squared plus x is greater than 15. So 2x squared plus x is greater than 15. Well, if you remember, the first thing that we have to do is we have to make sure that one side is equal to 0. My personal preference is to keep the highest powered term positive. The 2x squared is my highest powered term. I'm going to go ahead and keep that positive, so I'm going to keep it right where it is. So I'm going to subtract 15 on both sides of my inequality. Subtracting 15 will give me 2x squared plus x minus 15 is greater than 0. Now we subtracted 15 on both sides. We did not multiply or divide by a negative number, so we don't have to worry about flipping the sign. So we're still good. Now what we have to do is we have to find those cut points. Well, what you kind of have to look at here is you have to look at this left side and say, okay, this is just like a regular quadratic. I need to factor this, or you might have to use the quadratic formula or whatever you need to do to get the solutions to that left-hand side. So we're going to go ahead and factor this one because I believe this does factor. And again, if you're not as good with the factoring, this is a good chance to practice some of that. So I know I've got to have a 2x and an x. That's what gives me the 2x squared. I'm going to have some kind of a multiples to give me negative 15. The only multiples I can think of to give me negative 15 are going to be 15 and 1, one of those being negative, and 3 and 5, one of those being negative. 15 and 1 I'm pretty sure is not going to work. So I'm going to try the 3 and the 5 here. I'm going to put the 3 here and the 5 here. And I'm going to check my outside and my inside here to see if that's going to work. So I've got to, if I do the outside here, I'm going to have 6x, whoops, should have been yellow. There we go. Going to have 6x, and inside I'm going to have 5x. Well, I can subtract 6x minus 5x to give me the 1x for the middle. So that means that my middle values here, that has to be minus, that has to be plus. So now if I did my outside, I would get 6x inside minus 5x. That would give me the 1x from the center. So we're pretty good right there. That's going to be what we're looking for. And that still has to be greater than, there we go, greater than 0. So now how do I find those cut points? Well, or the boundary points. It's very simple. You're going to solve each one of these things just like you would have before. You set them each equal to 0 and solve. And this is going to give us our boundary points. On the first one, we'll add 5 to both sides. And then we'll divide by 2. So we get a boundary point of 5/2. On the other one, we just simply subtract 3. And we have a boundary point of -3. Now I'm going to set this up just like we did before. I'm going to set this up as a number line over here. And all I'm going to put on that number line are my boundary points. Now I do have to make sure that they are in numerical order in the correct place. So we're going to use -3 here and 5/2 over here. That's the numerical correct order. So here's what we do. We are going to test values. I'm going to test some value to the left of -3. I'm going to test something over in this region right here. Any value. And when I test it, I'm going to plug it back in right here. I'm not going to plug it back into my original. I'm going to plug it back in right here, and I'm going to show you what we're going to do. So let's test a value that should be relatively easy. Let's take -4 and test that, because -4 is in that circled green region right there. So if I test -4, if I plug -4 back into my 2x minus 5 and my x plus 3. So I'm going to do 2 times -4 minus 5, and I'm going to do -4 plus 3. I just picked -4 to plug in. So if I test that, I'm going to get, let's see, I'm going to get 2 times -4, which is -8, minus 5 more is -13. I'm going to get -13 out of the first parentheses. And the second parentheses, I'm going to get -4 plus 3, which is -1. When I multiply those two negative numbers together, I'm going to get a positive 13. Is positive 13 going to satisfy my inequality from right here? Well, I wanted my value to be greater than 0. 13 is definitely greater than 0. So this is a good section. This section right here works. This is exactly what I was looking for. All right. So I put a check mark up in there. That's going to indicate that section is good. Let's check something in between -3 and 5/2. Well, the easiest value I can think of in between those two things is 0. So let's go ahead and plug in a 0 into my x and see what happens. So if I do 2 times 0 minus 5 and then 0 plus 3. So 2 times 0 minus 5 is -5, and then times 3 is going to be a -15. That is definitely not greater than 0. That's a number less than 0. So this section does not work. That's out. I don't want that section. I don't want anything in between -3 and 5/2. Let's check on the other part. Now let's check anything greater than 5/2. So it's going to circle that one in green. We're going to check something out here. 5/2 is 2.5. So let's check 3. It's probably the easiest value to use. Don't make your values really big or anything like that and make them difficult to use. Just keep it in a relatively low range if possible. It's just easier. So we're going to check 3. So we're going to go 2 times 3 minus 5, and then 3 plus 3. So 2 times 3 is 6, minus 5 is 1. And then 3 plus 3 is 6, and when I multiply 1 and 6, I get positive 6. Positive 6 is greater than 0. Again, going back to the original equation, I was looking for greater than 0. So this is awesome. This one works. So we're going to check that region. So now I have my two regions. I have my solutions. I have where my polynomial here is greater than 0, which is what I want. And it is greater than 0 as long as x is in the realm less than negative 3. So x has to be less than negative 3, which means it could start as low as negative infinity and go up to negative 3. And I have to check this piece right here. There was no equal to symbol on the bottom there, so I cannot include the boundary point. I cannot include that negative 3. So I'll put a parenthesis on it. And then I also have the section where x is greater than 5/2 because it's that other green circled section. So I've got to start at 5/2. Once again, I cannot include the 5/2 because there was no equal to symbol, but it can go all the way up to positive infinity, and this is the solution.